It feels like in just the last couple of years, the entire playbook for building with artificial intelligence has just been, well, thrown out. And in its place, a whole new discipline has sprung up, one that's changing technology as we know it. I'm talking about a brand new field that has just exploded onto the scene almost overnight. And the crazy part, it's already reshaping the entire tech landscape at a speed that is, honestly, it's hard to even wrap your head around. So this all leads to the big questions, right? What is AI engineering really? And why is it suddenly the fastest growing field in tech? That's what we're going to break down today. Okay, so first things first, we have to get a handle on the sheer scale of this thing. This isn't just a little bit of hype. We're talking about a genuine, modern-day gold rush for developers and for companies. And look, I'm going to make a pretty bold statement right here at the start. The tools that these AI engineers are using, they're gaining traction faster than any previous software engineering tools ever. And yeah, we've got the receipts to back that up. Seriously, this isn't just a gut feeling. The data is absolutely staggering. Just look at this chart. The bars you see for AI tools like AutoGPT, they completely dwarf the growth of previous game changers like Bitcoin or even React. I mean, we have never seen developers flock to a new technology this quickly. It's unprecedented. So the big question is, how did this even happen? What was the key that unlocked the door, taking AI from these super expensive, locked-away research labs and putting it directly into the hands of pretty much every developer out there? Yeah, what was that magic ingredient? That one single breakthrough that kicked off this whole revolution? Well, the answer, believe it or not, comes down to one core concept: self-supervision. It's a really brilliant idea. Instead of needing humans to sit there and manually label tons of data, the model basically teaches itself. It's kind of like learning a language just by reading a massive library of books, instead of someone handing you a dictionary. So let me break that down. The old way, supervised learning, that meant you needed like armies of people to sit there and label data. This is a cat, this is a dog. It was super slow and ridiculously expensive. But the new way, with self-supervision, the models can just learn from the massive, unlabeled ocean of data that's already out there, the entire internet. And just to put a number on that cost, right? The famous ImageNet dataset, it cost over $50,000 just to get it labeled by hand. Self-supervision just, poof, made that massive financial roadblock disappear. And that's what allowed these models to scale up to the incredible sizes we see today. And that scalability created this incredible evolution. We went from these small, specialized models that could only do one thing to huge, large language models in 2018. And now we have what we call foundation models. These things are general-purpose powerhouses. They get text, but they also get images, code, you name it. And this is the raw material that today's AI engineers are working with. All right, so now we have these super powerful foundation models, and they're available to pretty much everyone. What happens next? A total explosion of new and mind-blowing applications. So let's take a look at what people are actually building with this stuff. This donut chart here gives you a really good snapshot of where the open source community is putting its energy. You can see the biggest slice by far is coding tools. It's over a third of all projects. But right behind that, you've got this incredible innovation happening in image and video, writing assistants, and all sorts of conversational bots. Let's dive into coding for a second. We're talking about way more than just simple auto-completion here. GitHub Copilot is already a $100 million business. But then you have these other wild tools that can take a screenshot of a website and just turn it into working code. Or tools that let you talk to a database in plain English. No more complex queries, just ask a question. And the impact on writing? Just as huge. Get this, a study from MIT found that when people used ChatGPT, they weren't just 40% faster at writing tasks. The quality of what they wrote actually went up by 18%. That's a game changer. It's a massive productivity boost, especially for those of us who, maybe don't love writing. Then you look at the creative world, and the growth is just off the charts. Midjourney, the image generator, they hit 200 million in revenue in about a year and a half with a tiny, tiny team. It turns out that because AI is probabilistic, it's good at guessing, it's perfect for creative tasks. You can generate professional-looking product ads or even headshots, all from just a simple text prompt. Okay, so that's the what. We've seen the kind of amazing stuff being built. But now let's shift gears and talk about the how. Because this is where the actual job of being an engineer has been completely turned on its head. This quote right here really nails it. The whole focus has shifted. Today's AI engineer, They're not spending all their time trying to build these massive models from the ground up. Nope. Their job is to take the powerful models that already exist and become experts at adapting them to solve a very specific problem. And this table breaks down that change perfectly. On one side, you have the traditional ML engineer. Their world was all about building models and that painful search for labeled data. But now, look at the modern AI engineer. They start with a powerful model already in hand. Their key skills are totally different. Prompt engineering and, this is a big one, evaluation. How do you test and control something that can give you a different open-ended answer every single time? Okay, so let's say you're ready to build something with this stuff. How should you even approach it? Because it's one thing to get a cool demo working, but it's a completely different challenge to build a real product that's reliable, safe, and actually valuable. And honestly, this is the hurdle every single AI builder is facing right now. Getting that wow moment, that cool demo that blows people's minds, that's the easy part. Turning it into a real-world product that people can depend on day in and day out, that's a whole other ballgame. There's actually a great framework from Microsoft for thinking about this. It's super simple. Crawl, walk, run. You start in the crawl phase. The AI is just a background tool, helping out a human who's still in charge. Then you walk. Maybe you let the AI interact directly with your own internal employees, where the stakes are a lot lower. And only after you've proven it's safe and reliable, only then do you let it run and start interacting with your actual customers. So if there's one big idea to take away from all of this, it's this. The whole game has changed. We've shifted away from the super expensive, specialized work of building models from scratch and moved into a new era of building on top of them. It's more creative and way more accessible to everyone. And that really leaves us with a final, and maybe the most important question. As it gets easier and easier to build with AI, the challenge is no longer, can we build it? We know we can. The real question, the one this new generation of engineers has to answer, is about purpose and responsibility. The question is, what should we build next?